new assignment. So I'm actually uploading new assignment today. Does that make sense? Because today is the last day that you can turn in the current assignment. Does that make sense? Okay. Okay, so I want to welcome you to this class, and of course, we are counting down to the final. Final has a very huge weight, right? I need you to pay more attention this time around. Okay, so when you're in class, please be focused. Okay, be focused. Okay, so I want to welcome you to this topic, comparing more than two means. And this is taken from chapter 14. Okay, comparing more than two means. In the outline, you're going to be introduced to analysis of variance, because we normally use analysis of variance where we are comparing means in more than two populations. I'm going to say that again. We use analysis of variance when we are comparing means in more than two populations or more than two groups. Of course, you realize that what we did before midterm 2, I walk you through chapter 10. And in chapter 10, I walk you through how we can compare means and proportions in two groups, in two populations. So what we want to do in chapter 14 now is an extension of what we did in chapter 10. Chapter 10 focused on two groups, but chapter 14 now will be focusing on more than two groups. And I need you to pay attention, like I said. Pay attention. Okay, I'm actually going to start with motivating example. Okay, I need you to pay attention, like I said. Okay, there's an example here. Okay, what is the most effective method for treating anorexia? Okay, they want to know the most effective method of treating anorexia. 72 anorexic teenage girls were randomly assigned to one of the three treatments. The first treatment group received cognitive behavioral therapy, in which girls are taught to identify the thinking that triggers their eating disorder and to replace it with other thoughts meant to prevent this behavior. The second treatment group attended family therapy, and the third group served as a control group and did not receive any therapy. Each girl was weighed before a treatment began and weighed again upon completion of the treatment. Of course, you can find the data here. Now, what are we trying to do? They got three different groups. Okay. Before that, we got three different groups. Then this is fall under more than two groups. Now, the first two groups are experimental group, because the first two groups receive therapy. Okay, I said that they receive different therapy, but the third group receive no therapy at all. Okay, when we are conducting experimental design, okay, experimental study, we normally create a control group. Okay, the control group receive no treatment, even though they're going to receive something, but it's not treatment. We call it placebo. Has anybody heard about placebo? Okay, so placebo does not have any effect. Now, I need you to pay attention now. Okay, pay attention now. Now, we're actually going to have three averages. Don't forget, the response variable here is the weight. Okay, it's weight gain. That is the response variable. Now, the first group going to have mean weight gain after completing cognitive behavioral therapy. Okay, another mean weight gain after completing family therapy. And the third one, mean weight gain with no treatment. Here we got three different means. And when we have three different means, the question now is, are any of the treatment better or worse than the others? Okay. So, and that is, are there any significant differences among these means? We actually want to answer the question if there is any statistical significant differences among these means. If we want to do that, okay, let me tell you this. You know, the goal is to use analysis of variance, okay, to compare the mean of more than two groups. But let me tell you this. Why is it that we, we cannot use the idea of chapter 10? Please, I need you to pay attention. I need you to listen, pay attention. All what I'm going to be saying today, there's a lot of final exam questions. That's why you need to pay attention. Okay? Now, why is it that we may not be able to, why is it that we cannot use the idea of chapter 10? Okay? And I'm going to tell you the reason. There are four reasons why using the idea of chapter 10 is not going to work comparing more than two groups. Because the idea of chapter 10, we can only compare two at a time. Okay? Like if I want to use the idea of chapter 10 now, okay, I need you to take a look at this formula. I want to know the number of tests, the numbers of pairwise comparison tests. G here represent the numbers of groups. Based on the example that I just cited right now, we got three groups. It means G equal to 3. Now, if G equal to 3, if I want to know the numbers of tests, okay, I'm actually it's going to be 3 combination 2, which is the same as 3 into 3 minus 1, okay, divided by 2, okay, and that's going to give me 3. So the formula here is actually to figure out K. And what is K? K will be the numbers of pairs. Numbers of pairs. When I say pairs, if I have 3 groups, okay, I can compare group 1 and group 2. That's number 1. Group 2 and group 3. That's number 2. Group 1 and group 3. That is making it 3 that we got right now. Okay. Now, what if in a situation where the numbers of group is 4? If I want to figure out the number of studies, you're going to see right now. If the numbers of group equal to 4, I'm actually going to have 4 into, using the same formula, 4 into 4 minus 1 divided by 2. And that will be 4 times 3, 12 divided by 2. I'm actually going to have 6. Okay. Now there's something I need you to pay attention now. Okay. You see that when the number of groups increases, the number of pairs, the numbers of pairwise comparison also going to increase. Now, I'm actually want to give you the number one reason why we cannot use the idea of chapter 10 on this. Number one reason is that using the idea of chapter 10, where we actually going to compare them pairwise, we're going to have a pairwise comparison. Okay. The reason why it's not going to work is because it will increase type 1 error. Please pay attention. Number one reason why we cannot use a pairwise comparison for situation where you got more than 2 groups. Number one reason is the probability of type 1 error will go up. How am I going to know? Okay, you're going to see something now. The probability of type 1 error will increase if I use idea of chapter 10. How? Take a look at the formula. Okay, family-wise error rate. Family-wise error rate, okay, which is the type 1 error, probability of type 1 error is actually 1 minus into 1 minus alpha raised to power k. Please pay attention. Please pay attention. Okay. When k equal to 1, when k equal to 1, when k equal to 1 actually means I only have just a pair to compare, just one pair. That was what we're doing in chapter 10, right? When k equal to 1, one pair. When k equal to 1, when I plug in k equal to 1, can somebody tell me for extra credit? This is going to become what? When k equal to 1. Plug in 1, where you see k. 1 into 1 minus alpha raised to power k. Okay, when k equal to 1, what does it become? Is that what? Yeah, so what, simplify that. What is it going to be in the end? Okay, you're very close. Yeah? Huh? Alpha. It's going to be alpha. Send me a message for extra credit. If you plug in k to be 1, it's going to be 1 minus 1 plus alpha. When you expand, that would be alpha, right? Okay? So which means when k equal to 1, alpha remains the same. Don't forget, alpha is a level of significance. It's also called the probability of committing type 1 error. Okay? But when k equal to 2, when k is more than 1, for more than 2 groups, k is not going to be 1. K will be more than 1. When k is more than 1, okay, that value is going to go up. For instance, let's assume alpha is 0.05. Okay? Please pay attention. If alpha equal to 0.05, let us try this. When k equal to 3, for instance, okay, why am I using k equal to 3? The other time for 3 groups, number of of tests is going to be 3 when we use that formula, k equal to 3. If you plug in, if you do 1 minus into 1 minus 0.05, 0.05, okay, raised to power 3, okay, what you're going to get will be more than 0.05. If you calculate that, what you're going to get. But you're only going to get the 0.05 if k equal to 1. The moment k equal to 2 or more, if k is more than 1, then the level of significance, which is the maximum probability of committing type 1 error, will go up. And that is the reason why we cannot use multiple comparison tests here. This is the reason why we cannot use the idea of chapter 10 for situation where the numbers of group is more than 2. Does that make sense? So number 1 reason is the type 1 error rate will be increased. We don't want that. Okay? The probability of type 1 error rate is going to be increased. Now, I want to give you number 2 reason now. Pay attention. Pay attention. Number 2 reason why we cannot use the idea of chapter 10 here is for holistic testing. Holistic. Okay? Holistic testing. And what do we mean by holistic testing? Okay, holistic testing. Okay, by holistic testing, using ANOVA, we'll be able to test the effect of a factor with multiple levels. I'm going to say that again. Using analysis of variance, we'll be able to test effects of a factor with multiple levels. Let me tell you this. The factor here is therapy, but therapy has levels. What are the levels of therapy? Cognitive behavior therapy, 1. Family therapy, 2. No therapy, 3. That's a categorical factor. It's like you're looking at the effects of therapy on what? Who can tell me? We're looking at the effect of therapy on what? Who can tell me? On what? On the weight. Did you say weight? Yeah, send me a message for extra credit. We're looking at the effect of therapy of therapy on weight. But the therapy here is categorical factor. An analysis of variance will enable us to do that. Okay. Number 3, reason. Number 3, reason is efficiency and interpretability. Efficiency, efficiency, okay? This is justifying. Let me tell you the efficiency and interpretability, okay? And interpretability. Now, what have we been doing? We've been talking about the reason why we need to use analysis of variance instead of a pairwise comparison. Okay, number one reason why we need to use analysis of variance instead of a pairwise comparison. Okay, instead of a pairwise comparison, number one reason is that using analysis of variance will be able to control type 1 error rate. But using the idea of chapter 10, what will happen? That will increase type 1 error rate. But analysis of variance will enable us to control for type 1 error rate. Number two, I just talked about holistic testing because the analysis of variance enable us to test the effect of a categorical factor. When I say categorical factor, I mean factor with levels on a response. And number three, now I talk about efficiency and interpretability. What do I mean by that? If I'm actually going to use idea of chapter 10, okay, imagine situation where we have so many groups. Okay, I told you the other time, when you have 4 groups, the number of tests will be 6. It means if I want to use the idea of chapter 10, I'm having 6 tests. 6 tests means I'm going to have 6 text statistic value and I'm going to have 6 p-values. That's a lot. Okay, 6 p-values. Okay, but analysis of variance will provide us with a unified conclusion where we only need 1 test statistic and 1 p-value. Does that make sense? Because we are simultaneously testing the effect. We're not looking at it one by one. No, we're not looking at it one after the other. That's not going to save time. Okay, and then the last reason, handling handling variance. Handling variance. Now I need you to pay attention now. Handling variance. Okay. Now I'm going to tell you the reason. I'm going to tell you what I mean by that. Okay. If you actually go by way of chapter 10, there is no way chapter 10 idea doesn't account for variance. But analysis of variance, that's why it is called analysis of variance, because it's going to account for variance. What do I mean by variance? Please pay attention. What do I mean by variance here? There will be variance within, there will be variance between. Do you know that I'm going to use some girls, some subjects here, right? I'm going to use some subjects here. I'm going to use some subjects here. If I measure the weight of the people here, there will be variation among them, right? Even though they receive the same cognitive behavioral therapy, they're actually going to have different weights. Some subjects here also going to have different weights. Some subjects here, they're going to have different weight. Okay, variation within, that's what we call variation within the group. Analysis of variance will enable you to account for variation within a group. Not only that, it will also enable you to account variation between the groups. Look at that, variation within and variation between. Okay, and let me tell you this. Being able to account for variation within and variation between, okay, then that is going to lead to a result that will be reliable because it has account for variation. I remember when I was doing this in college. The first time I did this in college was in 2002. Okay, how many years ago? 22 years ago. Yeah, I did this in 2002 in college, and the first question I asked my professor then is, we're comparing means. Why do you call it analysis of variance? Why not analysis of means? Are you getting me? You know, what are we comparing? We're comparing means, right? But we are calling it analysis of variance. And the response I got is this: even though we're comparing averages, but we are analyzing variation, because there's going to be variation within, there's also going to be variation between. And that's why the you know, And I was made to realize that analysis of variance is the splitting or the breaking down or the partitioning of the sources of variation into two components. The first component, variation within. The second component, variation between. So when I had variation within to variation between, then we got to two sources of variation. And that is what analysis of variance does. Okay, now, and I want to go into analysis of variance now. Since I've justified the essence of analysis of variance, we use analysis of variance when we are comparing means in more than two groups. And you know what? We got different type of analysis of variance. Okay, we have one-way analysis of variance. One-way analysis of variance is talking about one variation. Like you're talking about one categorical factor with levels. Two-way analysis of variance is going to talk about two categorical factors with level. But right now, I want to walk you through one-way ANOVA. It is called one-way ANOVA because we only have one categorical factor. Now, if you take a look at this, okay, the only factor here is therapy. That's what I mean. We have a single factor here, and it is called therapy, but it has levels. How many levels? 3 levels. That levels means is the numbers of groups. The levels means group. Does that make sense? Okay. What in another study, I may have this. Maybe I also have another factor that may be region, where the subject come from. Region, where the subject come from. Region is also a categorical factor. Or maybe I'm talking about race, or I'm talking about gender. Another factor may be gender. Gender is also categorical. But here, I'm only talking about one factor. Because I'm talking about one factor, then I'm going to be focusing on one-way analysis of variance. Okay? Now, one-way analysis of variance. Now, you know what I want to do now? With one-way analysis of variance, I want you to get familiar with notations. What are the notations that we use? I'm going to start now. The first notation is G. G represents the numbers of groups, the numbers of population you want to compare. Does that make sense? That's what G represents. Now, don't forget, if G represents the numbers of group, we're going to have a sample size of subjects, right? We're going to have a sample size for group 1, sample size for group 2, sample size for group 3, and so on like that. Okay. NI represents sample size of the ith group, the sample size of a particular group. Just like the example I was showing you the other time on cognitive behavioral therapy, how many sample size do we have in that group? Okay. For family therapy, how many do we have? For no treatment, how many do we have? We're actually going to use N high. N1 would be the sample in group 1. N2 would be the sample in group 2, and so on like that. Does that make sense? Now, oh my God, I needed to pay attention to this guy. An uppercase N is the overall sample sizes. It's like I'm adding a sample, the number of sample in each group. I added them together, and that would be the overall sample. We use notation uppercase N. Does that make sense? I need you to get yourself familiar with the notation. Okay, get yourself familiar with the notation. Now, after knowing that, the next thing I want to walk you through, take a look at this. What do you see? Y bar high. Y bar high. That is the mean for a particular group. Okay, like here now, in the example that I'm citing here, we're actually going to have 3 means because we got 3 groups. Okay, don't forget, some people here, they're going to have different weight. We're going to add them up. We're going to find the average. We're going to find the average here. We're also going to find the average here. So we're actually going to have average for a particular group. And the notation for that is Y bar I. Y bar I. So when I equal to 1, that will be Y bar 1. Y bar 1 is the mean from group 1. Y bar 2, the mean from group 2. Y bar 3, the mean from group 3, and so on like that. Now, apart from having, okay, the group mean, we're also going to have the overall mean. Oh my God. I need you to pay attention now. Okay. There's a difference between the overall mean and the mean for a particular group. If I want to get overall mean, okay, I will need to add all the observations in all groups together and divide by totality. That will give me the overall sample mean. Overall sample mean is different from mean for a specific group. Does that make sense? Okay, the notation for overall sample mean is just Y bar. Do you see Y bar? The other one is Y bar high. Where you see Y bar high, that one is talking about the mean of a particular group. But where you see just Y bar, that is the overall mean. It's all not the same. Now, the next one is XI. Okay, let me tell you this. If you can calculate mean from each of the group, we can also calculate standard deviation for each of the group. Does that make sense? If I can calculate the mean for each of the group, I can also calculate the standard deviation for each of the group. Okay, now the next thing I want to walk us through. One way ANOVA, don't forget, compare population means among G different groups. Now, I'm going to walk you through the process, the procedure for conducting analysis of variance tests. But you know what? I know the first thing is going to be absorption. Okay, absorption is number one. And when I'm comparing means in more than two population, absorption is that I must be taking random sample, okay, on each. Okay, and not only that, I'm actually going to use the principle of randomization in assigning subjects to groups. If I have three groups, okay, if I have three groups, the way we're going to assign subject to group, okay, any group can receive any subject. We're actually going to use principle of randomization. Now, and another thing in the assumption is that each population has to be normal. Each population, each group must follow normal distribution. Okay? I think I'm going to walk you through. There's so many assumptions when it comes to analysis of variance tests. I'm going to review that next. But you know what I'm concerned again, what I'm going to focus more today is how do we formulate hypotheses when it comes to this. Now, I need you to pay attention to H naught. Because we got several means. We're going to write equality, mu1 equal to mu2 equal to, depending on the numbers of groups. But you know what we're going to write in the alternative? In the alternative, we're going to say at least two of the population means and they are unequal. Okay, two are unequal. I just give you an example on the therapy now. I will quickly cite example in medical field. Okay, now let's say you have 4 different vaccines. You want to look at the effectiveness of 4 different vaccines in preventing COVID. Okay, let's say vaccine A is Pfizer, vaccine B is Moderna, vaccine C is Johnson & Johnson, and vaccine D is AstraZeneca vaccine, manufactured in the United Kingdom. Now, we got 4 different vaccines, and we want to compare them. Okay, now under the H naught, I'm actually going to have mu1 equal to mu2 equal to mu3 equal to mu4. Under the alternative, I'm actually going to say at least 2 of the population means are unequal. And if I want to conduct this experiment, we're actually going to look for individuals that we want to vaccinate. Let's say if I identify 100 individuals now, 100 individuals, okay, we're going to randomly assign them into these 4 groups. No, when we are going to use what I call principle of randomization. Anybody can go to any group, like the way we're going to assign using instruction of chance. Okay. Now we're going to have some that will get vaccine A, some will get vaccine B, some will get vaccine C, and some will get vaccine D. Okay. Then we're actually going to compare maybe average of infection rate or something like that. Okay. We want to see which of the vaccine, you know, whether they are equally, uh, maybe they have equal, or they are equally effective in reducing infection rate or not. Okay. Because there are more than 2, we're actually going to use the idea of analysis of variance. Now, I need you to pay another attention now. Analysis of variance is actually going to work so good because it will enable us, to partition total variation into 2. There's something that we call between variation and within variation. I told you the other time. Let me start with between variations. Between variations, we mean how much the means of each group differ. That's what I mean. How much the mean in each group differ. That's what we call between variation. But if I'm talking about within right now, okay, if I'm talking about within right now, is if if some people get vaccinated with Pfizer vaccine, okay, they actually going to have the Pfizer vaccine will have different effect on them. The whatever treatment we have different effect on them. Okay. Now, if we measure the response, we want to see, you're going to see that there's going to be a variation within them. That's what we call variation within group. The variation within group will tell us how much variability is there within each separate group. There will be variation within a group. There will be variation between groups. So analysis of variance helps us to split, to break down, to partition the total sources of variation into 2 components here. Okay, to between variation and within. Okay, now I need us to pay attention right now. We are back at box plots. Okay, there's a multiple box plots. I need us, our goal here is to compare the mean of several groups, several population. Okay, why are we doing an analysis of variances? Before we go into analysis of variances, before we start comparing means statistically, at times we may want to have a kind of preliminary, as part of preliminary investigation and analysis, we can draw a comparative box plot. I need you to take a look at this. Here, what happened? The means are very close, right? Look at the mean. Do you see the mean? They're very close, right? Between groups. Okay? If we're talking about mean, talking about this guy here. Does that make sense? Okay. They're very close. Can you see that? And even though different exists here, even though different exists, but the difference that exists here, the difference that exists here is due to chance. When something is due to chance, when different is due to chance, then it means the difference is not very much pronounced. It means there is no statistical significant difference. But let's go to the next one. Let's go to the next one. We're gonna go to the next one. Take a look at this guy. What can you say about the mean? There's a huge difference. Look at it. Look at this one. Look at that one. That's a mid. There's a difference between them, right? Okay, this one is not due to chance. Okay, but the difference here is due to chance, but here is not due to chance, and that was why I said, plot for plot 1 and plot 2. I said for plot 1, variation between samples mean is small in comparison to variation or variability within. Now, if you take a look at this, now I need you to pay attention here. The variation between mean is very small, but variation within is large. Compare this box. with this box. In this box, do you see that? Spread out. In this one, shrink in. What happened? You know, if you want to use interquartile range, what is the formula for interquartile range? Q3 minus Q1, right? The interquartile range here will be bigger than the other one here. Okay, so why is it that difference exists here? The difference exists here is just due to within variation that is large. But the difference that exists here is not attributed to the within variation, but between variation, between groups. Does that make sense? Because when you take a look at the within, okay, on the second, the within variation is small. Now, this is the deal. When within variation is larger than between, the difference is not significant. But you know when the difference is significant? When between variation is larger. When between variation is larger. And let me tell you this, by the time we start F-test statistic on Wednesday, the test statistic we're going to use for ANOVA, we call it F-test. It is a ratio of between variation to within variation, which means between variation divided by within variation. Does that make sense? Now, take a look at this now. And I want to walk us through this. How, because in the analysis of variance, the formula we're going to be using is a ratio of between variation to within variation. I'm going to say this again. Between divided by within. Within is going to be in the denominator. Between is going to be in the numerator. Does that make sense? Now, let's now talk about between variation and within variation. Now, let's start with between variation. Please pay attention. Pay attention. I want to first talk about between variation. Okay? The between variation, don't forget the other time, between variation, talk about how the means differ, the mean of different group, how they differ. If I want to get that, I need what I'm actually needing SSG. What is SSG? Sum of square deviation for groups. How am I going to get sum of square deviation for group? I need you to pay attention. Summation. I start from 1 to G. Ni, what is Ni? The number of sample within a particular group. Y bar I, the mean of a particular group minus Y bar the overall mean squared. That's the formula I'm going to use to get the sum of square deviation for group. And the moment I get the sum of square deviation for group, okay, I need degree of freedom. We need to divide by degree of freedom. So dividing by degree of freedom, I'm actually going to get this. That is MSG. MSG is going to be sum of square deviation of a group divided by G minus 1. Okay. Now, that guy, MSG, is what is going to be at the top for F statistic. Because if this is where I'm going, I want to get F statistic, but I'm going to do that on Wednesday. It is MSG, okay, MSG divided by MSE. Okay, now what I'm trying to show you right now is how do we get MSG? We get MSG, we first get SSG. After getting SSG, then we divide by G minus 1 to be able to get MSG. And after getting MSG, then the next thing that I'm actually going to do is to figure out, okay, variability within groups. Now, for variability within groups, what are we going to do? For variability within groups, please pay attention. Variability within groups. Look at this formula here. I'm actually going to compute standard deviation for each group. I will square each standard deviation, then I will multiply by the sample size in that group, then I will sum it together. That's what I got mean. Ni minus 1 multiplied by Si squared. What am I trying to say? If I have 10 people in this group, okay, maybe in one group, I got 10, in another group, 8, in another group, 7, because at times we could have different number of subjects in each group. Now, the degree of freedom is going to be, for this one, it's going to be 9. For this one, it's going to be 7. For this one, it's going to be 6. You know what I'm going to be doing using this formula? I'm going to say 9 times what is the standard deviation, the square of the standard deviation for that group. You know, you have a standard deviation for each group, you square it, okay? Plus, you're going to do 7 multiplied by the square of standard deviation for group 2, okay? The square of standard deviation for group 2, then plus 6 multiplied by the square of standard deviation for group 3. Whatever you get is what we call the sum of square error. And after getting sum of square error, we need MSE. The degree of freedom here is going to be n minus g. Okay, that's why you're seeing this formula here. Do you see that formula now? Sum of square error divided by n minus g. What is n? N is the totality of the sample size. If I want to get the totality of the sample size now, it's just going to be 10 plus 8 plus 7. Okay, the totality of the sample size minus G. What is going to be G? Numbers of groups. So the moment I got my MSG and my MSE, okay, then I'll be able to get ANOVA test statistic. Okay, that I'm actually going to show you on Wednesday. Now, another thing I'm going to talk about is this. If you have SSG, which is the sum of square deviation for group that we call between, and you have SSE, which is the sum of square deviation for error, then I can get the overall. I can get the overall variability. The overall variability is called SST. SST means sum of square total. Sum of square total. So sum of square total is sum of SSG plus SSE. Okay, if I get SSG and SS, I can add it up. Okay, if I don't want to do that, another way to get that is to be subtracting mean from overall mean from each observation. Okay, now take a look at this. We're actually going to make use of this on Wednesday, because you know what I want to do on Wednesday? What I want to do on Wednesday is actually, okay, what is a test statistic? Okay, if I have data set, okay, if I have 3 groups, okay, how can I compute, okay, the test statistic? How can I compute the p-value? And how can I take decision? Because we're going to compute the test statistic here. We're also going to compute the p-value. Then we'll be able to take a decision. Now, before you go, I need you to spare me for 2 minutes, because it's 104. We still have like 6 minutes, but for 2 minutes to say this. Final exam has a very huge weight. I'm going to say that again. Final exam has a very huge weight. I will advise that from now on, you listen carefully in class. You pay more attention. If an area is not clear to you, ask question. If you're shy, like maybe you don't want to ask question in class, visit with me during my office hour. If you are in my office hour and maybe you meet your colleague in my office hour, and maybe you don't want your colleague to maybe to hear the question you are asking, because some of you may think, oh, maybe I'm asking a stupid question. There's no question that is stupid as far as I'm concerned. But maybe you want me to like meet you in private, what I'm just going to do is to put you in a breakout room in Zoom, where we are in a breakout room. The other student will not hear the question you are asking. But the most important thing is, I just want you to reach out when you get stuck. We are moving towards final exam. On Saturday, I'm actually going to release final exam practice question. I'm going to say that again. I'm releasing final exam practice question. Make sure you reach out when you get stuck because final has huge weight. Your as for exam two, your result will be shared this Friday. Make sure you all stay safe and have a lovely day. Bye for now, everyone.